All right, guys, I figured I'd make a quick little video right now on classifying triangles. Okay, so you can see right here that we have four different triangles right here, and we're going to classify them using the side lengths, and we can classify them using angle measurements. Okay, so let's look at the first one. Well, let's look at some of these terms. Equilateral. So what is an equilateral triangle? Well, when you're equilateral, all right, so right here, that means all the sides are equal. Okay, so all the sides are equal. So if it's make sure I spell it right, equilateral. Okay, I could put under here, all sides, oh, I hate when that does that. All sides are equal. They are the same length. Okay, all sides are equal. Then we have isosceles, all right? So isosceles right over here. What is an isosceles triangle? Well, isosceles means that you have two sides that are the same length. So we have two sides, same length. Oh, I think I've spelled that wrong. Length, the same length. Okay, two sides, same length. All right, then you have scalene. Scalene is that last term, and you go scalene. Just sounds weird, but scalene means that none of the sides are equal. So I'm going to throw that here in red. Scalene, and we'll put no equal sides. All right, so you have equilateral. All the sides are the same length. They're all equal. You have isosceles. Two of the sides have to be equal, the same length. And then you have scalene, no equal sides. They're all different measurements. Okay? So now, with all that written out here, let's take a look. I'm going to move my marker to orange. And let's see what we have. So for A, okay? A right here. Well, we look at A, and you see that you have these tick marks. See these tick marks, the little dashes on the sides? When you have those are going to let you know what sides are equal. Because you don't have to take out your ruler here and actually measure the lengths of the sides. All right? You don't have to do that. So you could say, well, how would I know if the length of the side is the same length? Well, you would have that tick mark and that tick mark. So that means that this side on the left and this side down here on the right is the same length. So if I have two sides that are the same length, what would this triangle be? This triangle would be an isosceles triangle, because two sides are the same length. Now, you go over here and you look at B. We have a tick mark, and a tick mark. That means that this side, and this side are all equal. So if all three of those sides are equal, that makes this an equilateral triangle. Now, let's look at C. C could be a little tricky. Now, we know for C, you notice this little box or square in the corner, because it's a square corner, and this means it's a right angle. Well, because this triangle has a right angle, that doesn't help us identify the type of triangle based on the sides. That would actually go over here, where we're going to classify this triangle with angle measurements. So I'm going to jump ahead and say, well, I know this triangle has a right angle in it by that box. So I know, like I said, I'm getting ahead of myself. This would be a right triangle. Because once you see that right angle, a triangle could only have one right angle at most, right? So that is a right triangle. But let's get back to classifying it using its side lengths. Okay, well, there are no tick marks here. So that means none of these sides are equal. None of them are the same. So this is actually a scalene triangle. It's actually a scalene right triangle, is how you would say it. Okay? And now we could look at the last one, and you'll notice the same thing. There are no tick marks. Okay? They're definitely not all the same size, so we know it's not an equilateral triangle, and none of those sides are the same length. So this is also a scalene triangle. Okay? Now, so we have those terms. I'm going to erase those for a second. And now we go to our angle measurements, right? So our angle measurements, we know we have acute, and we think about that. Like it's cute, like a puppy. Like a puppy is really small. It's acute, okay? So an acute angle, if it's an acute triangle, all of your angles will be less than 90 degrees. So I should write all. This is the symbol for angles. All angles less than 90 degrees. Okay? Then you have a right triangle, which we just went over. So a right triangle has to have a right angle. So a right triangle, I'm going to put it here, go here, has to have a right angle. Okay. And then the last, an obtuse triangle. Obtuse is big. So an obtuse triangle here has to have an angle greater than 90 degrees. Okay, so that's what we have here of how to classify them using angle measurements. So now, if I go back and I look at A, well, I look at A and I'm looking at this corner right here, it's definitely greater than a right angle. So that's going to be an obtuse. So this is actually an obtuse isosceles triangle, or an isosceles obtuse triangle. Okay? You look at B. B is an equilateral triangle, and for you to have three angles that are the same, an equilateral triangle has to have angle measurements of 60, 60, and 60, which would all be acute. And then we did see, we said that was a scalene right triangle. And then the last one, you could look here and say, well, we know it's scalene, and we know that angle is going to be greater than 90. This corner is greater than a right angle, which means that is a obtuse scalene triangle. Okay, so that is how you can look at some triangles and classify them using the side lengths, and how you can classify them using angle measurements.